Okay, so this is the best I'm going to be able to do for now. A little late on getting the video put together, so what I'm going to ask you to do is kind of play this video simultaneously next to your PowerPoint, and I'll tell you when I switch slides. That way you can switch and follow along with me because I can't seem to figure out how to get the PowerPoint up so I can have an audio, like a voiceover. Anyway, this will have to do. Just ignore any funny faces I make. Just pay attention to the PowerPoint. So beginning on the first slide here, we're going to be talking about the physical and cognitive development in infancy, and rightly so. That's how we start out in this life as infants, if you ignore the guppy stage. But anyway, so we've also got a socio-emotional part of the lecture in infancy as well, but right now we're just really going to focus on physical and cognitive development. So we'll go ahead and go to that next slide, slide 2. So at birth, an infant really has few of the physical capabilities we associate with being human, but really over that next 12 months they make a lot of big strides. They're capable of sitting, standing, stooping, climbing, and usually walking within that first 12 months of life. And we've got two particular patterns of growth I want you to know about. One is the cephalocaudal pattern, and this is the belief in the sequence in which the earliest growth always occurs at the top, at the head. And with physical growth and differentiation of features, they gradually work their way down. So as a fetus, we develop from our head down, and that's a cephalocaudal pattern of growth. The same pattern occurs in the head area with the brain, and as well as sensory motor development. So, for example, infants are going to see objects before they can actually control their torso. So we'll go on to the next slide. Next is the proximodistal pattern, and this talks about growth and how it starts at the center of the body and moves toward the extremities. Okay, so we had the cephalocaudal, which is the head down, and now the proximodistal, which is the center out. Okay, so for example, infants can control the muscles of their trunk before they can control their hands, and they can control their whole hand. You see, they'll tend to reach something like this before they control their fingers. So it starts from the center and grows out. Okay. And I've got some statistics here about the height and weight of the average North American newborn. Usually they're about 20 inches long and 7.5 pounds. And most newborns are going to lose 5 to 7% of their body weight before they adjust to feeding. Once they adjust to feeding, they're going to grow very rapidly. They double their birth weight by 4 months old, and usually nearly triple it by their first birthday. And at 2 years old, the average child is going to be 32 to 35 inches tall, which is nearly half of their eventual adult height. Into the next slide, slide 4. So with regards to the brain, we're not born with a complete functioning brain. The brain is going to continue to develop after birth and throughout infancy and even later in life. It's developing very rapidly during infancy, though. It's like you've heard the saying that a child's brain's like a sponge. Well, it's very true, but it's growing and swelling. That's why it's very important that the head of the infant is protected, and the baby should never be shaken, like this guy in the picture is doing. Don't do that. Shaken baby syndrome unfortunately affects hundreds in the U.S. each year. I guess people are just shaking their children. It's very strange to me. At birth, the brain is going to weigh around 25% of its adult weight, and it's going to be about 75% of its adult weight at age 2. So the baby's head's often like falling over, and their head's heavy. Their brain is heavy. So that's why it gets harder for them to hold up their head until those muscles develop. Go on to the next slide. And particularly areas of the brain, they don't mature uniformly. the forebrain is really of the greatest interest during infancy. That includes the cerebral cortex and several structures beneath it. And the cerebral cortex is that what makes the brain look wrinkled, wrinkly, and it has two hemispheres, a left and a right. And there's four main areas in each hemisphere, and those are called the lobes. You've got your frontal lobe, occipital lobe, temporal lobe, and parietal lobe. And really, I'm not going to get into what each of the functions are of those. Trying to stay away from this being a neurology class. But if you go on to the next slide there, I do have a picture of each. And I can tell you the frontal lobe contains a lot of your executive functioning. That's one thing that I always remember from my neuropsychology classes. But it's important to know that the lobes are found in each hemisphere. So you have a left frontal lobe and a right frontal lobe, but they're not identical in anatomy or function. The left frontal lobe doesn't necessarily have to look like the right frontal lobe, and we know that there's areas of the right frontal lobe that differ in function from the left frontal lobe function. And that's really called lateralization, and that's the specialization of a function in one hemisphere or the other. For example, we know that our right hemisphere is responsible for visual input, organizing visual spatial input, whereas our left hemisphere is more specialized in language. And those hemispheres have already started to specialize at birth. On to the next slide. There's important differences between the areas in an infant brain and an adult brain, and those are both been documented at the cellular and structural level. As far as cellular, we see changes in the neurons. In infancy, we see a myelination, and that's the process of encasing those axons with fat cells. You can kind of see on that drawing there what the axon is. And that encasing, that myelination, is going to increase that connectivity among the neurons, okay, so that they can communicate to each other faster. We also see changes in the regions of the brain during that time between infancy and adulthood. The way that the regions look as an infant look different from how they will when you're an adult. Next slide. So this shows the dendrite density. You've got a newborn there with, and the dendrites are the little, I always call them like tree branches. So they're reaching out, and the dendrites reach out and connect with parts of the neurons, right? So at a newborn, you can see there's few, but even at 1 month, there's several, and to adults, and to where there's a lot. On to the next slide. So we can't underestimate the benefits of early experience and its effect on the brain. In particular, experiences are going to determine how changes in the brain occur. Before birth, we know that it's mainly biology that directs how the brain establishes those wiring patterns, right? But once they're born, it's really the experiences that are going to lead to the development of the brain. So that constant inflow stream of sights, sounds, smells, different touches, language, and eye contact are all going to help shape those neural connections. So you really, you see a lot of things around babies' cribs, mirrors, and bells, and shapes, and all those things are really good to help them connect those neurons, right? It makes sense. On to the next slide. So we know that babies tend to sleep a lot, and maybe some of you wish that your child would have slept more. But the amount of sleep that an infant gets is going to vary from infant to infant. But typically, they'll get about 16, 17 hours a day. And the most common reported problem is that nighttime waking, whether it be because they're wet, whether it be because they're hungry. But it's interesting because if you know anything about sleep, and you sometimes in psychology we know we need to strive to enter that REM sleep, and REM stands for rapid eye movement. Well, as adults, we don't get much of that. We actually only spend about a fifth of our time in REM sleep. But in infancy, that's our time when we spend the most time in REM sleep. And with sleep, we have to talk about sudden infant death syndrome because that's typically when it occurs. Um, and this occurs when an infant stops breathing, and usually happens during the night, and then dies suddenly without an apparent cause. It's the highest cause of infant death in the U.S. currently. It's very sad. They found Some of the researchers have found that sudden infant death syndrome does decrease when the infant sleeps on its back. And researchers believe that when they lie face down, it impairs their infant's arousal from sleep and restricts their ability to swallow. So they're not strong enough to arouse themselves and move themselves up if they're suffocating, so they tend to just suffocate. So just that next slide there is just an illustration to show you what you do and do not want to do with your baby sleeping. Go on to the next slide. So nutrition is very important. You've got a growing child, and with that always comes the debate of breastfeeding versus bottle feeding, and this is always a personal choice. There are numerous benefits to breastfeeding. It decreases the chance of obesity because it helps maintain an appropriate body weight, appropriate weight gain. It lowers the risk of sudden infant death syndrome. And babies who are breastfed usually experience fewer gastrointestinal infections and lower respiratory tract infections as well. And breast milk's got a lot of those good live cultures and probiotics that your baby really needs. There hasn't been any evidence of difference in cognitive development. Like some really hardcore breastfeeding moms will like to say that their babies are smarter because they breastfed, but actually there's no difference in cognitive development has been found, nor in cardiovascular functioning. The big thing with regards to psychology is that many professionals are going to argue that breastfeeding facilitates a healthy attachment between the infant and mother because they're receiving that skin-to-skin contact. And with that, the dopamine, serotonin, those feel-good hormones are released in the mother's brain. She loves her baby, the baby loves her back, and that really comes from the skin-to-skin contact. However, in my opinion, I think that you could probably get that same skin-to-skin contact if you use a bottle. Just hold your baby, up to your chest, hold them up to your neck, get that skin-to-skin contact, and make eye contact with them. Go on to the next slide. Nutritional needs are going to vary so vastly among infants, so it makes it difficult to determine what your baby should get exactly. And that's all that slide is meant to, talk about. It's just that we really don't know. Some infants are born with, a sensitivity to milk products. There's all kinds of different allergies and that kind of thing. So, go on to the next slide. Okay, now we're going to talk about motor development. Basically ask the question of how their motor skills develop and which skills do they develop when. So a lot of timetables here. The dynamic systems view says that infants are going to assemble motor skills for perceiving and acting on their environment. In this case, perception and action are coupled together. In order to develop these skills, they have to perceive something in their environment that motivates them to act, right? So if they don't see something they want, they're not going to act and develop the motor skills to achieve it. Once they develop that, they're going to then use their perceptions to fine-tune their movements. And so basically, you can think of motor skills as being solutions to the infant's goals, okay? I'm going to learn to raise my head up, so I can see my mom, that kind of thing. So I've got some links down there. You can pause the video and watch. There are YouTube clips. So the devil of baby attack is just funny. That's just my humor. Esther Thelen was one who really did some research on the development of motor skills in infancy. And then there's a good video about the typical. It shows, compares and contrasts typical and atypical development in a 2-year-old, and as with regards to motor functioning. Go on to the next slide. So again, with the dynamic systems view, it says when infants are motivated to do something, they might create a new motor behavior, right? As I said about raising the head. If you lay a baby on its stomach, it loses sight of its mother. It wants to see its mother, so his or her mother, I shouldn't call it in it. So it's going to raise its head, right, to see. And that new behavior is going to be the result of several converging factors. How their nervous system has developed, their body's physical properties, and the possibilities that their body gives for the movement, the goal the child is motivated to reach, and environmental support for the skill. But according to this dynamic systems view, it's important to know that motor development is not a passive process in which genes dictate. There has to be something in the environment that the baby wants to get to. To leave a baby in its crib all day, every day, their motor development is going to be delayed. So the infant is actively putting together a skill in order to achieve a goal within the constraints set by the infant's body and its environment. Go on to the next slide. So you've got several reflexes that you're born with in infancy. And reflexes are just built-in reactions to stimuli. Like one of my reflexes is to run when I see a shark, or swim. You can't really run, but I think I would run on water. Anyway, these reflexes are going to govern newborns' movements, and they're basically genetically carried survival mechanisms. They're usually automatic and involuntary. It allows the infants to respond adaptively to their environment before they've had the opportunity to learn. So all babies are born with reflexes, right? They have to know what to do, or else they'll, especially in terms of the animal kingdom, come out and not make it very far if they don't have those natural born instincts. Human babies have that as well. So, for example, if you submerge a baby in water, the infant automatically knows to hold its breath. It doesn't know, it does it automatically. Plug in my laptop here before it dies. So, you've got the rooting reflex, which occurs when the infant's cheek is stroked or the side of its mouth is touched. The infant's going to turn its head towards, the source of the touch. And I've got a video there that illustrates the rooting reflex, if you want to pause the video and click on that. You've also got the sucking reflex. So newborns are going to automatically suck on an object that's placed in their mouth. And you also have the moral reflex, and there's a video for that one as well. That occurs in response to a sudden intense noise or movement. So with infants, if you make a loud noise, they're going to tend to arch their back and throw their head back and fling their limbs out in response to the noise. What that does for survival, I'm not sure, but on the next slide, I've got a whole table of the infant reflexes. So when the Babinski is really what you want to look for. They'll stroke the sole of the foot. If it fans out the toes or twists the foot in, is what you want to look for as a healthy response. And there's also where, these reflexes don't stick around forever, so that's going to disappear after 9 months to a year. So you can go over those in your own time. We'll go ahead and go to the next slide. So there's also, in terms of gross motor skills versus fine motor skills, which we'll discuss in a minute, Gross motor skills are skills that involve large muscle activities, such as moving one's arms or walking. Those are all gross motor functioning, gross motor skills. So there's a table of, when you can expect your infant to start doing some of those gross motor skills that they're expected of, such as lifting their head, rolling over, supporting some of their weight with their legs, pulling self to a standing position, and eventually standing alone. Go on to the next slide. In the second year of development, there's some different gross motor. By 18 and 24 months old, toddlers can walk quickly for a short distance, no matter how cute and wobbly it may be. They can balance on their feet while playing, kind of in a squatting position. You'll see them sitting on their feet. They can walk backward without losing their balance, stand and kick a ball without falling, stand and throw a ball. May not be accurate, but they can throw it, and they can jump in place. And that's by the second year of development. Next slide. So this gets into the fine motor skills. Fine motor skills involve those finely tuned movements, such as grasping a toy, using a spoon, buttoning your shirt, anything that involves finger dexterity. So your ability to thread a needle is fine motor skills. And infants really have very little control over their fine motor skills at birth. They do have, though, the many components that will later become finely coordinated movement. So you can see those gross motor function of moving the arm can eventually go to grasping for a toy. That onset of reaching and grasping, that makes a significant achievement in the infant's ability to interact with their environment. Once they can actually reach and grasp, they can start sensing more and sensing things. They're grabbing things, they're putting things in their mouth, all kinds of things. But like any muscle, both fine and gross motor skills need to be exercised. The more they're exercised, the better your baby's going to develop. Go on to the next slide. So this talks about sensory and perceptual development. We talked about motor, so what do babies do when they get their hands on things? How do they construct their environment? Well, they take in much of their information through their senses, and each sense is important to their development. Sensation occurs when information interacts with sensory receptors, and those are your eyes, ears, tongue, nostrils, and skin. And perception is the interpretation of what is sensed. So your sensation is occurring as you're looking at me right now. Your perception of whether or not I'm doing a good job is, completely different. So, for example, airwaves that contact the ear may be perceived as noise or as musical sounds. Maybe some of y'all are heavy metal fans, maybe some are not. Those of you who are not may perceive heavy metal to just be a bunch of noise, right? Whereas someone else may view it as being a musical masterpiece. Go on to the next slide. Okay, so when they're studying the infant's perception, we've got the visual preference method, which a lot of researchers use, and what they're going to do basically there is just measure the length of time infants attend to various stimuli. So they're going to track their eye movement, or they're going to, time basically how long an infant's going to look at a ball, or a doll. And then you've got habituation and dishabituation. And in this process, stimulus is presented a number of times. So they're going to show the ball, take it away. Show the ball again, take it away. Habituation is decreased responsiveness to stimulus after a repeated presentation. So you show an infant a ball one time, they may be really excited. Take it away, show it again and again and again. Eventually, that habituation is going to occur. It's not going to be very exciting anymore. Dishabituation, though, is the recovery of a habituated response after a change in stimulation. So, show them a ball, they've developed a habituation for, they don't really care too much about it. Show them a doll a couple times, they develop a habituation, but then you show them the ball again, well, recover that habituated response. Okay. Also, some equipment has really helped facilitate our study of infants' perception, such as high-speed computers, videotape, etc. And a lot of researchers nowadays in lifespan development are going to use eye tracking software. They want to know what the infant's looking at, how long it's looking at it. And there in the corner, that's a picture of a baby with an eye tracking headset on. Go on to the next slide. So with visual perception, some theorists may say that the infant is just this, kind of thing, and like it's just absorbing all these experiences, but really newborns tend to perceive their world in some type of order. There's visual acuity and color. Generally their vision is very poor at birth, but it improves quickly. They can discriminate between colors by 8 weeks old. Perceiving occluded objects, which means objects that are partially covered, right? So if I do this with my water bottle here and I cover it, you know that there's another half of a water bottle back there, right? For the first 2 months, infants are not going to perceive occluded objects as being complete. This half of a water bottle is just half of water bottle to them. After that, they start to develop, the idea of what an occluded object is and that it's complete, even though they can't see it. In about 3 to 5 months old, they develop the ability to track briefly occluded moving objects. Okay, so if here on the next slide, there's a illustration there. So they're able to watch the ball as it goes across, but once it's gone, they can't follow it anymore. So that's what it's looking at. How well the infant is able to follow that ball, even though at some point they're not able to see it. Next slide. There's also the issue of depth perception, and Gibson and Walk did a pretty interesting study in 1960. They constructed a miniature cliff with a drop-off that was covered by glass. They placed 6 to 12-month-old infants on the edge of the visual cliff and had their mothers coax them to crawl into the glass. And they found that most of the infants would not, so they were able to perceive the depth and knew not to go off, across the glass. And if you go to the next slide, there's a picture of what that cliff looks like. So you can see the baby's there and they've got their hands there, but they know something's not right. Go on to the next slide. Okay, so other senses. Hearing. Infants can hear the mother's voice while in the womb during the last 2 months of pregnancy. They can't hear soft sounds as well as adults after birth, though. They're more likely to hear those high-pitched sounds. But even newborns can determine the general location from which a sound is coming, but they're more proficient by 6 months of age. As far as touch and pain, they respond to touch, the rooting reflex, right? And they're thought to be resilient to pain, but that's not really true. And your book gives an example of circumcision in particular. Babies cry and wail during circumcision because generally anesthesia wasn't used, but they're soothed very easily. Newborns can differentiate among odors. They've done studies where infants tend to show a distaste for smells like rotten eggs and that kind of thing, and prefer smells like vanilla and that kind of thing. But it does take time for them to develop their odor preferences, right? And taste. Sensitivity to taste is even thought to be present before birth. They injected some kind of fluid into the amniotic sac, and they found a sucking reflex in the infant. So, compared to a different type of thing that was injected. Okay, infants tend to engage in intermodal perception, and that's integrating information from two or more sensory modalities. Okay, most perception of ours is intermodal, and early exploratory forms of intermodal perception exist even in newborns. So they'll look at it, they'll put it in their mouth, they'll rattle it. They're integrating those senses. As far as the nature, nurture, and perceptual development, the whole development of the individual, there's the full portrait of the perceptual development. Includes the influence of nature, nurture, and also a developing sensitivity to information. Okay, so all of those are involved. Go on to the next slide. Now we're going to talk a little bit about the cognitive development. Excuse me. Piaget was really, Jean Piaget was the forerunner here in the development of this. He really paints that unifying story of how biology and experience sculpt cognitive development. He says that we build mental structures that help us adapt to the world. Okay, remember when we say cognitive and cognition, we're talking about thinking, memory, perception. So these mental structures are going to help us adapt to the world, and adaptation involves adjusting to new environmental demands, right? So he said that children do actively construct their own cognitive worlds. Information is not just poured into their minds from the environment. They're intaking the information from their environment, and they're doing things with it, which we'll discuss now. Go on to the next slide. So in the processes of development as described by Piaget, we've got schemes, which are actions or mental representations that organize knowledge. And these are created by the infant's developing brain as they seek to construct an understanding of the world. So they're creating behavioral schemes, in particular with infants, such as physical activities, whereas toddlers create mental schemes and cognitive activities. So they know that if they cry, their mom will come and feed them. Right? That's a scheme. It's a different knowledge. We've also got assimilation and accommodation. So assimilation occurs when the children use their existing schemas to deal with new info or experiences. So you have to think about, in their little brain, they're taking in a new experience, and they categorize it into this little filing cabinet of the various things that we organize in our brain. Accommodation, on the other hand, occurs when children adjust their schemas to account for new info or experience. So they're really having to change the way that they think about things with accommodation. Go on to the next slide. They participate in organization, just as adults still do. Organization is grouping of isolated behaviors and thoughts into that higher ordered system so you can sift through. And really, if this is kind of difficult to imagine because it's something that's not easily seen. But imagine that if we weren't able to cognitively organize all of our experiences, how confusing our world would be. It would be very difficult, right? If someone cut us off in traffic, we wouldn't know to smile or laugh or be angry. So it's the same way for infants. So children are going to cognitively organize their experiences, and that helps them make more sense of the world. And then you've got equilibration and stages of development. So because adults still experience this too, but children are going to inevitably experience cognitive conflict, which your book terms as disequilibrium. And that's brought on by inconsistencies and the like. So you have one thought about this set of behaviors, and then something comes along that challenges what you thought. Okay, and that's what's happening here. That's what creates disequilibrium. So Piaget says that this equilibration is the mechanism by which children shift from one stage of thought to the next. So they're capable of taking in that new information that doesn't fit and altering the way that they think so that it does fit. I hope that makes sense. On to the next slide. So with infancy, they're in the Piaget terms the sensory motor stage, and we'll talk about several of his stages as throughout our entire course here. And that lasts from birth to about age 2. Infants are going to construct an understanding of the world by coordinating sensory experiences with physical motor action. So really, infants are sensual beings, right? They're going to use their senses that they gather from the motor movements, and that's how they're going to organize their world. Object permanence is part of that sensory motor stage, and that's understanding. We talked about the water bottle, right? That's understanding that objects continue to exist even when they cannot be seen, heard, or touched. So that's very acquiring this idea of object permanence is one of the most important accomplishments for an infant. So next slide. So another part of cognitive development is obviously learning, remembering, conceptualizing, and I didn't go into detail into these either. I didn't really see the need. Conditioning in particular, I did go into more detail because it's really part of the behavioral part of it. So conditioning, that's when the consequences of the behavior are thought to influence the probability of the behavior's occurrence. Infants can learn through operant conditioning. So if an infant's behavior is followed by rewarding stimulus, the behavior is thought to be more likely to reoccur. So they're learning that way by getting their behaviors being rewarded. Also attention. They're learning by paying attention to things. Things are grasping their attention. They learn through imitation, imitating those around them. Also memory, so committing things to memory is part of learning. And then concept formation and categorization. That gets back to what we were talking about, forming those schemas, forming concepts about the relationship between objects and people, and categorizing those things into the different filing cabinets of the brain so that they can be used to learn. Next slide, final slide here. This is on language development. So the kind of tailors how language develops here. First, you've got the babbling and the gestures of babies. It's cooing, crying, reaching, that kind of thing. And then they start to recognize language sounds, okay? They may start to make the different sounds. Okay, the babbling turns into actually making sounds of letters, those phonemes. Then they'll start saying their first words, right? Once they get those sounds and they're able to cognitively put them together. And then they'll start the 2-word utterances in infancy. So book there, wear ball. They're not getting those different filler words in. So that's really the extent of the language development in infancy. And you've got biological influences and environmental influences that are going to have effect on that language development. So as far as biological goes, being able to speak and understand language requires a certain vocal apparatus, okay, as well as a nervous system with specific capabilities. So infants can be born with, different types of vocal apparatuses. Also, maybe their nervous system's not fully developed. That's going to affect how their speech develops and how they're understanding language. Even auditory children who often will have to get the tubes and stuff in their ears will end up having difficulty, maybe speech impediment, difficulty understanding language because hearing is required to, perceive language accurately. And also environmental influences. If your infant's not in an environment where they're exposed to language, you can't expect them to learn the language. So it's very important that you have good support and involvement of caregivers and teachers in the baby's life for that development to occur appropriately. So, I believe that's it. If y'all have any questions, shoot me an email. I will be available through email, and I can try to clarify something up as best as I can. And I will see y'all in class next week.